JSON Web Tokens is a well-known and popular open standard that defines a compact way for securely transmitting information between parties as a JSON object. And for some reason, there have been a lot of people asking me to make a video about JWT in Go. So that's what we're going to do today. We will dive into the format itself to make sure we understand how JWT works. We will also implement a secure Go server that can issue JWTs as well as verify them. And we will also dive into some security best practices for using JWTs. By the way, the suggested pronunciation for JWT is actually JWT, as stated by its creator, but it just sounds a little bit weird to me, and I heard mostly people call it just JWTs or just tokens. And the most common use case for JWTs is authorization. Once the user is logged in, each subsequent request will have a JWT, allowing user to access some protected resources on the API server. And so on this diagram, we can see that user exchanges credentials for a JWT token by contacting the authorization server, and then sends this JWT via authorization header to a resource server with some protected API routes, which otherwise won't be available for this user. And you may notice that these two parties are separate, authorization server and resource server. Technically, it could be the same application, but in a little bit bigger systems, they usually separate with a central authorization server and multiple resource servers. Back to our JSON Web Tokens format. So you've probably already seen that JSON Web Tokens look something like that. It's some sort of gibberish separated with a dot. It's actually not gibberish, it's base64 encoding. And it's very important to understand it's encoding, it's not encryption, because everyone can decode base64. But let's look at these three parts here. So the first one will be the header. It's the type of the token and the algorithm with which we sign this token. So in this case, it's HS256, which is HMAC SHA-256. The second part, it's payload itself. So that's the important part where we put so-called claims. It could be the user IDs, when this token expires. So when we look at the specification, you can see so-called registered claims. These are the claims that are commonly used by authorization servers. So issuer, subject, audience, and expiration time. As well, you can put any custom claims into the JSON Web Token payload because it's simply a JSON object. And so we take the header, we base64 encode it and put it as the first part of the token. Then we take the payload, again base64 encode it, put it as the second part of the token. And then we use the algorithm that's defined in the header to sign this token. And usually for signing, you need some secret key or PAM key, and the signature will be the last part of the JWT. And so signature plays a very important part in the security because we can verify then that no one has tampered with our payload data. But coming back to this base64 problem, as you can see, it's right here, and you can encode this part in the middle payload and everyone can see it. So that's why it's very important not to put any secret information in the JSON Web Tokens unless you encrypt it. So yes, it's possible to encrypt some information, put it into the token and then base64 encode it. It's not commonly used because usually these tokens tend to be quite small. And so if you want to play with JWT and put these concepts into practice, you can visit jwt.io and basically see how JWT works, right? You can change anything in the header, in the payload, put some secret key here and basically generate new JWT. You can also copy paste JWT from somewhere and paste it here and then kind of unpack it and see what's inside. Cool, let's move to the application part. And in Go, the most popular package to work with JWTs is golang-jwt/JWT. It has this page. So it's very easy to use, right? Let's go get it first. Yeah, and then first maybe go mode, maybe init, do JWT demo, then go get. And for this example, let's use the Echo router. That's actually my favorite router out there. It's quite minimalistic and performant. And it also has nice abstraction. So for example, it has JWT middleware already. So let's also install this, right? So let's install it first. And actually, I just noticed that their JWT middleware has a nice documentation and even better example that we can take probably as is and just tweak it a little bit. Alright, it also uses Echo JWT package from LabStack and their middleware. So let's also go mod tidy that. All right, we need to save this file first. So let's review this code and make sure we understand how it works. So first we define the type for our claims, and here we actually inject the registered claims. That's what we went before. It's issuer, subject, expiration time, and so forth, as well as we add the custom claims, name and admin. So that's probably what our application needs. Now let's skip this route and then go to the main function and see what's happening there. So in the main function, we initialize the echo object, we put some logger middleware, we have the login route, which is still open. And so basically anyone can call our /login endpoint because there is no authorization check, there is no middleware that does that. And then there will be a restricted so-called group. So we can do in echo e.group, and then all the endpoints defined on this group will kind of go through the same logic. So the same middlewares will apply. And in this case, we add one middleware. So we do this ruse, and we use the echo JWT with configuration, and configuration is defined here. So it tells what is the format of the claims. So that's the type JWT custom claims, as well the sign-in key that we need to use. Here, that's what I want to change, and we'll come back to this in a second, but let's first see these endpoints. So restricted, right, simply prints the username from the JWT claims that we put before, but let's review the login. And so what our login function needs to do is to validate the user credentials, then if they're valid, build the claims for JWT, and then sign the JWT and send back as a response. And obviously, if the credentials are not valid, we are sending error unauthorized. So here would be, obviously, we are not checking the errors. Maybe, for example, I don't know, database check, right? Then we set the custom claims. So username will obviously come somewhere from the database. The fact that user is admin or not, maybe as well. But actually, usually you don't put such information in JWT. At least I don't like to do that. I like to keep JWT as minimal as possible. Kind of, if we can use only registered claims, that's even better. So we can see we set expires at in 72 hours. Then we have claims. We can sign them. We sign with the HS256, which is HMark SHA-256, and I'll change it in a second. And then yeah, so we sign it with some secret. So we've seen the secret here and there. And yeah, we send a JSON response back. And so a lot of articles online show us to use HS256, but it's also important to understand that it's not the most secure way, because first of all, it's symmetric, meaning that we need to share this secret between the party that kind of signs this token and the party that verifies that. So, and then if somewhere it's leaked, then it means that we need to rotate it everywhere. There are fortunately better solutions such as RSA, which is asymmetric, meaning that we have a private key and public key, and if maybe public key gets leaked, we can just rotate it, keeping the private key as is. And so we can do it here in this example. I believe there will be here sign method RS, right, 256 claims, and then instead of passing the secret here, we'll pass the, so in the sign we'll need some private key. So I'll add it in a second. And then in the verification part, we also need to change the sign-in key to our public key. So we'll define them in a second publicly, as well as we need to tell what's the sign-in method. So I think it's sign-in method. So it's either will be string RS256, or I think we can also use, I think it's JWT sign-in method, right, and then maybe .name. So what's left for us to do is to generate these private and public keys. So let's go to console and use OpenSSL here. So we can do OpenSSL gen RSA. So out, let's do private key.pem, and then cool. So we have the private key. And now again, using OpenSSL and having our private key, we can generate the public key. So I think it's OpenSSL, I think it's RSA minus pub out, and then in our private key, and then out our, I believe like that. Cool, so we have both private key and a public key. And kind of because we have a single application, both public key and private key will be used here. So let's just maybe add a init function for simplicity and load these keys. So we can do public key data maybe. Now I believe that JWT package has the function to parse this key. So we can do I think it's JWT.parse RSA, yeah, exactly, from PAM, and then we pass the public key data. Let's define them as variables here. And basically we should repeat the same for private key, right? So let's review. In the init function, we open the public key and private key, save them, kind of parse them and save into the variables. These are global variables. Then, right, when we sign, we use the private key. Then when we verify, we use the public key. Awesome, let's see if all of that works. So we save the file and we run our server. And then what do we need to send as credentials? I believe it's John and then password, like that. So cool. So we can try first. Right, so it's post, right? Right, localhost 4042. And then we can get our token. So I believe it's right, my bad. We got not found. All right, so it's because we didn't send the login. Now again, cool. So as you can see, we have the log message, obviously, and then our token. So let's get it. And then we can call our, what that was called, API. Yeah, just /API, and it's get. So we do the same. So now we have token. We use API. So it's get, right? So as you can see, by default, it says missing or malformed JWT because there is nothing in provide. So that's kind of the guard of our API endpoint. But by default, we can use the authorization header. So that would be authorization bearer, and then we paste our JWT here. And as you can see, if we call it with valid JWT, it prints welcome Jon Snow, and that was the name that we set into the JWT claims. And as I mentioned earlier, we can always go to jwt.io and then paste our token here and kind of verify. So algorithm would be RS256, that's what we set here, and we will see our payload, right? So we are mixing the registered claims, so the default one, as well as the custom one, so name and admin. And yeah, you can play with signature, right? You can put your public key or private key here and then kind of regenerate or validate. And apart from JWT, there are also a bunch of JSON Web standards. And there's another great Go package called JWX from Lesterot-Go that has implementation for all of them. And they include things like JWK, JWS. So JWK is JSON Web Keys, then JSON Web Signature, JSON Web Encryption, and I believe JSON Web Algorithm. So they also can be useful when you're working with JWTs or a little bit more sophisticated system when you need to download the keys from somewhere, right, and put into your application and so forth. In a way, JWT standard is quite simple. It tells you what should go into the token, in which format, how to sign it, how to verify it, but it doesn't necessarily tell you how to use that. And if you're working with systems like Auth0, you will notice that there are multiple flavors of tokens. There are ID tokens, access tokens, refresh tokens, and so forth. They're all JWT tokens in a way, but the intent of them is different. And so in our application, we didn't differentiate what type of token do we have. For example, it could be ID token or access token. Usually when we use this token to call some API for authorization to access some specific resource, that's called the access token. And ID token is used to give to the client some basic user profile information. And before we finish, I would love to also mention some best security practices for handling JWTs. One I already mentioned is using the strong algorithms for signing these keys. So for example, RSA. Another would be to keep this JWT's payload simple and don't put any sensitive information there. Also embrace HTTPS because these tokens are sent over the network and they can be easily decoded with base64. And also pay attention to how you store these tokens. For example, on the front end, try not to save them in the local storage. And that's it for today. I hope it was helpful. Hit the subscribe button and see you later, nerds. Bye.